All right, for this lesson, I'm going to go into evaluation of functions using function notation. And in the last video that you all watched last week, I talked about function notation, where you have f of x instead of y, but they mean the same thing. So we're going to be using f of x instead of y, and we're going to be evaluating functions. That means we're going to take out a variable and replace it with a number, or we're going to take out a variable and replace it with a variable expression. This video is going to be split into 2 days, Monday and Tuesday. So you'll work on Monday, take notes on the video, and then on Tuesday you're gonna finish or make corrections to your inequalities word problem test, and then finish the second half of this video. Okay. All right, let's go ahead and get started. So let's just go through this. Let me get my pen up. What is a function? So we already talked about what a function is. A function is a relation in which every x is paired with only one y, one and only one y. So basically, x can't repeat or x can't cheat. You can't have x with like 0 and x with -2. Excuse me. I gave you something like an x of 2, 2. If that's my x, can't be with a y of something like that, okay? X, for every x, it can only be paired with one y. But I think you all understand it very well. We're going to go over the homework too today. Got so much stuff I got to do from last week. All right, let's take a look at the note. It says equations of the functions can be written in a form called function notation. This equation is a function because its graph forms a line that passes a vertical line test. So this equation is represented by this line. So if I drew vertical lines, then it would only touch that line in one spot, no matter where I drew it. Touches the line in one spot. So since the line is a function and the line represents the equation itself is a function. So instead of me using a y, I can use f of x because it's a function. So instead of y equals to x plus 2, we can write f of x equals x plus 2. Again, f of x is the same as y, and y is your range. So since y is your range and f of x is the same, then both of these represent your range. All right, so what we want to do is find the range. We're going to look at a certain range when we're given a domain. Remember, domain is an x value, and range is a y value, also known as f of x, okay? Says, how do you find the range of a function when it's written in function notation? I don't know why these little rectangular shapes on there. So if you have f of x equals to x plus 2, find f of 5. I want you to know that the number in parentheses, which is a 5 in this particular case, represents your x. So here x is 5, and it says find f of 5. So actually you're going to find your range when your x is 5. All this means is find the range when x is 5. And then you want to figure out what x is, look inside of the parentheses right in here, okay? So all you're going to do is take out x and replace it with 5. It says x is your input or independent variable. We talked about that in the last video too. Your input, again, is your domain, what you put in. I'm not going to go through this rule thing. I don't think you all need that. F of x is your output, what you get out. And I want you to keep in mind in and out. X is what you put in, and f of x or y is what you get out. Your output is your dependent variable, also known as your range, guys. All right, so I'm going to go back here. So I'm going to take x out and put 5 in. So instead of f of x, it becomes f of 5. In other words, what's my range when my x is 5? What's my range value when my x is 5? And then I'm going to take this x and replace it with 5 and then add the 2. You just follow your expression. So when my function is evaluated at 5, my range is 7. In other words, when I put in 5, I get out at 7, excuse me. So f of 5 just simply equals to 7. Basically, when you throw 5 in the place of x in your function, you get out a value of 7. That's all that means. All right, let's take a look at A in this particular case. It says if f of x equals 3x minus 1, you're going to find f of 2. So I know here my x is negative 2. So instead of f of x, it's f of negative 2. And then instead of 3 times x, I replace x with negative 2. So it's 3 times negative 2 and then minus 1. Just follow your equation, okay? So when I put in negative 2 for x, I end up with negative 6 minus 1. So basically, when I put in negative 2, I get out negative 7. So when I put in negative 2, my output is negative 7. So my domain is what you put in. And I put in an x of negative 2. And my range is what you get out of it after you put in a negative 2. My range was negative 7. But you would write your answer like this. F of negative 2 equals to negative 7. When you put in negative 2 for x, you get out negative 7 for your range or your y or your f of x. Or I could say my output. So many different names for the same thing. Dependent variable, all for y. All right, let's take a look at B. It says if f of x is 4 minus 3x. So if your function has an equation that's equal to 4 minus 3x, find f of negative 10. So I'm going to put in negative 10 wherever I see an x. So f of negative 10 equals to 4 minus 3. Instead of 3 times x, it becomes 3 times negative 10. And I am going to multiply first. So bring down your 4. And negative 3 times negative 10 is positive 30. So when I put in negative 10 into my equation, into x for my equation, I get out 34. Basically, when you evaluate that function at negative 10, your output is 34. I'm going to write it in words. The function, and the function is just the equation, guys. Evaluated at an x value of negative 10 is or equals 34. All right, let's take a look at C. Again, make sure you're pausing the video and taking notes for me, okay? If f of x equals 2x squared minus 2x minus 1, you're going to find f of negative 4. Okay, evaluate the function f at negative 4. And it doesn't have to always be f. I don't want to tell you that. It could be h of x. It could be g of x. I don't know. It could anything. It doesn't even have to be x. You can have something like this. A of c equals to, you could have c squared plus 4. That means, and then it says, it may say find a of negative 5. So I'm just telling you the letters don't have to be f and x, guys. Basically, that's what I'm trying to show you. So here in this particular case, your c is your input, and a of c acts as your range or your output, okay? So what you would do is you put in a c value of negative 5, into the function labeled A. That function is labeled A, because you're going to get different functions. I mean, like later on, you're going to see that you can have two functions you have to choose from, and you have to look at how they're labeled. But we'll talk about that probably in the video tomorrow. But in this particular case, you would take out C and replace it with -5. But again, the point of this is that the letters don't have to be F and X. All right, so here I'm going to have F of -4. I'm going back to the C. So X becomes -4. X is your input. That's your input variable, okay? So F of -4 equals to 2 parentheses -4 squared minus 2 times -4. You could have used parentheses there too. Minus 1. And I'm going to follow PEMDAS. If you have multiple operations, always follow PEMDAS, your order of operations. So I'll look to see if I have any parentheses. All right, I see parentheses here, but there's nothing to do inside of them. Now I'll look to see if I have exponents. Well, I do have an exponent. My exponent is right here. -4 squared. So I'm going to take -4 and square it. That's just -4 times -4, which is positive 16. So I'll replace this part right here with positive 16. So instead of 2 times -4 to the second power, it simply becomes 2 times 16 minus 2 times -4 minus 1. I just bring the rest of the stuff down. Okay, exponent's gone. Now move on to multiplication division. I see multiplication, no division. I'm going to work it from left to right. 2 times 16 is 32. -2 times -4 is positive 8. Minus 1. Okay, multiplication division gone. Now I just do addition and subtraction. You can do it from left to right. So that's 40 minus 1. So when I put in -4 in the place of x in that function, I get out 39. So F of -4 equals to 39. Again, make sure you're pausing the video and taking notes. Let's take a look at D. D says if g of x is equal to -x squared plus 4x plus 5, find g of 3. So I have been saying F because the function was labeled F, but here my equation or function is labeled with G, okay? So, hold on, I dropped my pen. It can be labeled with any variable. It's just written in function notation. So instead of F of x being your output, it's G of x is your output. But x is still your input value. So you got an x, something to put in for x, okay? For the variable x. I don't have my variable labeled as anything other than x there. But one thing I want you to do, guys, if you have a negative leading out with no coefficient is the number attached, I want you to rewrite it for me. If not, most of you will miss it. So instead of -x squared, put -1 times x squared. Put your coefficient in -1 plus 4x plus 5. And then use an x of 3 for your input, okay? All right, so let's put in an x of 3. When I evaluate G, the equation labeled G, at 3, at a domain or x of 3, I get -1 times 3 squared. You could have used parentheses there, guys. I just chose to use a times sign. Plus 4 times 3 plus 5. So you're going to have G of 3. And remember, I'm using PEMDAS because I got multiple operations. No parentheses. Any exponents? Yep. 3 squared. 3 squared is 3 times 3, which is 9. So you're going to end with -1 times 9 plus 4 times 3 plus 5. But just bring the rest of this back down. Exponent gone. Go on to multiplication division. All right, so no division. So I'm going to do a multiplication from left to right. -1 times 9 is -9. 4 times 3 is positive 12. And then bring down my plus 5. Now I can take care of my addition and subtraction from left to right. or you can group up your positives and group up your negatives. I'm just going to do it from left to right. Negative 9 plus 12 is 3. And 3 plus 5 is 8. So I know G of 3 is equal to 8. In other words, when I put in a 3, I get out an 8. If you ever see these things on an ACAP test, which you got to take in April, guys, and it tells you got a function machine. This is called a function machine. All it is input and output. You put in a 3 into the equation negative 1x squared plus 4x plus 5. So 3 goes in the place of x, and you get out 8. It's just input and output. And you don't have to use a function machine. Sometimes it helps students see what goes in whenever, and then you put your equation or your rule. A rule is just your equation or your function, guys. That's all. And you put it in the place of your variable, and you see what you get out. You put in 3, you get out 8. You put 3 in here. So don't let a function machine confuse you. It's just input and output. It's just evaluating expressions, all right? All right, pause the video and you try E. All right, this is what you should have gotten. It says if h of x is equal to x squared minus 7x plus 6, you're going to find h of negative 3. Notice now your output is h of x. Like I said, it doesn't matter the variable. G of x, f of x, h of x, it doesn't matter. It doesn't even have to be a x. Just know that whatever is in the parentheses is your domain. So since x is in parentheses, that's my domain. Since negative 3 is in parentheses, that replaces x, which is also my domain. Negative 3 is my domain. Let me write that a little better. All right. You can put an understood 1 if you want to. The understood 1 or the coefficient of 1 is not really necessary unless there is a negative in the lead, okay? They call it a leading coefficient. So you have h of negative 3 equals to negative 3 to the second power minus 7 times negative 3. I could have used a dot for multiplication. All right, so follow order of operations when you have multiple operations. No parentheses. Well, you do have parentheses. There's nothing to do inside of them. Exponent, yes. Negative 3 to the second power is simply negative 3 times negative 3, which is positive 9. All right, so I'm going to put positive 9 minus 7 times negative 3 plus 6. All right, so cross out E, get rid of your multiplication and division. I see multiplication. Bring down that 9. Negative 7 times negative 3. I'm going to look at it as positive. That's positive 21 plus 6. And all I have left to do is add. 9 plus 21 is 30, and 30 plus 6 is 36. So when I put in negative 3 and my function label h, I get out 36. So h of negative 3, well, the function evaluated at negative 3 equals 36. Now let's take a look at f. F, it says if h of x is equal to the absolute value of 2 times x, that's multiplication in there, plus 1, find h of negative 5. So I have h. I'm going to replace x with negative 5. And you all, I know that you need time to write this down. So again, I hope you're pausing the video to write these down, okay? All right, so I'm going to take out x and replace it with negative 5. Use my absolute value symbols. Instead of 2 times x, it's going to be 2 times negative 5. Put my absolute value symbol back on the right. All right. Work inside of the absolute value. 2 times negative 5 is negative 10. Now I can take the absolute value of negative 10. Well, what is absolute value? Absolute value is distance, and distance from 0 can never be negative. So, where distance can never be negative, guys, I don't care what it's from. It could be from 0, negative 2, 1, it doesn't matter. Negative 10 times, the absolute value of negative 10 is 10, and 10 plus 1 is 11. So when I evaluate that function at an x of negative 5, I get out 11. And that's all you do. All right, you're going to pause the video and try G. All right, this is what you should have. X here is going to be negative 4. And notice now the range is m of x. Again, just trying to reiterate that. Doesn't matter what your variables are, okay? All right, so I'm going to put m evaluated at negative 4. This function evaluated at negative 4 is going to be equal to 3 times negative 4 squared plus 2 times negative 4 minus 1. All right. Use PEMDAS, do the exponent first. Negative 4 squared is just negative 4 times negative 4, which is positive 16. Write the rest of this stuff back down. Okay. Multiply from left to right because there's no division. So you know what? 48. 2 times negative 4 is negative 8 minus 1. And then I'm just going to perform addition and subtraction from left to right. 48 minus 8 is 40 minus 1. So when I evaluate that function labeled m with an x value of negative 4, I get out 39. So m of negative 4 equals 39, and that's all you do. All right, you're going to pause the video and try h. But guys, it has a negative in front of it. So your leading coefficient is negative. So it's something I want you to do before you even start this problem. And you all should know I need you to put a negative 1 for the coefficient. So you're going to rewrite this as g of x equals to negative 1 times x squared minus 5. Then you can evaluate that function when x is 3. All right, you pause the video and do that one. All right, this is what you should have. Negative 1 times 3 squared minus 5. Take care of your parentheses first. 3 squared is 3 times 3, which is 9. So you have negative 1 times 9 minus 5. So now you end up with negative 9 minus 5. You're going to multiply with negative 1 times 9. And then negative 9 minus 5. I didn't mean to put that. Negative 9 minus 5 is negative 14. So when I evaluate that function with an x value of 3, I get out negative 14. Just as simple as that. It's just input and output, guys. Domain, range, independent, dependent. All right, I is a little different. I'm going to do I, and I'm going to tell you to pause the video and try J. Let me go over I. It says, what is the range of g of x equals to 3x squared minus 5 if your domain is negative 2, 0, and 1? Well, this time, how many x values do you have? Well, you have 3. You have an x of negative 2. You have an x of 0. And you have an x of 1. Remember, your domain is a set of x values. And your range is a set of y values or what you get out. That's your output. So basically, you're just finding the output. So you got to put your x value in the function. And your y value will take care of itself once you put in that x value. So in this particular case, in the first one, I got an x of negative 2. So I end up with g of negative 2. And you have 3 times negative 2 squared minus 5. Take care of your exponent first. So negative 2 times negative 2. A negative times a negative is a positive. Positive 4 minus 5. Okay, take care of your multiplication next. So you have 12 minus 5. And 12 minus 5 is 7. So g of negative 2 is 7. Okay. So it says, what is your range? Since you got your domain in set notation, I'm going to put my range in set notation because I have more than one. So one range value is negative 2. Let's figure out the other two. So I'm going to start off with an x of 0. So replace x with 0. 0 times 0 is 0. So you're going to end with 3 times 0 minus 5. And anything times 0 is 0. And 0 minus 5 is just negative 5. So I have another range value of negative 5. Now I'm just going to figure out the last one. G of x, write my function back down, equals to 3x squared minus 5. Now I get to plug in an x of 1. Sorry. An x of 1. So it becomes 3 times 1 squared minus 5. And 1 squared is just 1 times 1. So I end up with 3 times 1 minus 5. Take care of your multiplication because multiplication beats subtraction in order of operations. 3 times 5, 3 minus 5 is simply negative 2. Oh, I see that I wrote something wrong. And you all probably caught it. But when I put in an x of negative 2, I just caught it. When I put in an x of negative 2, I got out a y of 7. So this first one should have been 7. Then negative 5. And then negative 2. I wrote the x value down again. So I apologize. I caught it. Just caught it later. All right, so this represents my range when this is my domain. All right, you're going to pause the video and try J. All right, so again, these are your x values. So I have an x of negative 3. I have an x of negative 2. And I have an x of 1. And it uses y instead of f of x. That's a typo because we're practicing function notation. So I apologize. But you all have used y, so I'm just going to leave it. It's the same thing. That's my fault though, okay? So you have 2 times negative 3 squared minus 3 times negative 2 minus 2. Take care of your exponent first. Negative 3 times negative 3 is positive 9. Now I can take care of multiplication. From left to right, 18. That's going to be plus 6 minus 2. So I end up with 24 minus 2, which is simply 22. So one of my range values in my set, I'm keeping in set notation because you got 3 domain values. So I have 3 range values, okay? All right, let's try an x of 2. So y equals to 2x squared minus 3x minus 2. So it's going to be y equals to 2 times negative 2 squared minus 3 times negative 2 minus 2. So 2 times negative 2 times negative 2, because you got to do your exponent first, gives us positive 4. Bring the rest of this stuff back down. So we end up with 8 plus 6 minus 2. So that's 14 minus 2, which is 12. So 12 is also in our range set. And the last one, of course, plug in an x of 1. Write my function back down. All right, 2 times 1 squared minus 3 times 1 minus 2. Well, 1 squared is simply 1 times 1, which is 1. Write the rest of this back down. Then I can multiply. 2 times 1 is 2. Negative 3 times 1 is negative 3, or minus 3 minus 2. I could just say these are additive inverses, or they cancel each other out. I get negative 3. That's the route I'm going. Or you could have added and subtracted, or subtracted from left to right, okay? All right, so that is your range. All right, I think what I'll do, let me check my time on my video, is I'm going to give you a little practice on function notation. That's simple, guys. Like when I say simple, simple. And tomorrow what I'll do is I'll pick up here, because instead of your x value being a number, look inside the parentheses. Now your x value is some type of expression. But I'm going to give that to you today. I think this will pick up the second half tomorrow after the test. You'll work on this video. So it'll be K through the rest of these, which shouldn't take that long. And I'll say reasonable domain and range for when we get back after Thanksgiving break. All right. Just work on your homework. Again, it's going to be simple. It'll be like the ones I've given you. And that's it for today. Hopefully, you all will do much better on your inequality word problems correction tomorrow. Thank you, guys.